All right, let's do a quick recap of whatever we have discussed until now. And post that, we will take the discussion to the next level. So let me go here and open 360digitmg.com. Here you will have to go to mind map, and within the drop down you will find the mind map. A single click would expand that, would open this. However, to open or collapse any of the branches, you just need to double click. And we have discussed about CRISP MLQ framework, which stands for Cross-Industry Standard Process for Machine Learning with Quality Assurance. And within this, we have 6 phases. These two put together would be part of phase 1. And then you have phase 2, 3, 4, 5, and 6. Within phase 1, we have ideally 2 subcomponents. One is business understanding, another is data understanding. As part of business understanding, we'll have to record the business objectives, and we will also have to record the business constraints. Usually when we record the business objectives or business constraints, you confine the objectives and constraints to 2 to 3 words. If you feel that, no, I'm finding it difficult to represent objectives and constraints using 2 to 3 words, then you might want to use 4 to 5 words, right? And not more than a sentence. You cannot say that my objective or constraint would contain multiple paragraphs or multiple sentences. To the extent possible, we will have to use a term such as minimize or maximize. And project charter is the first document which gets created on any project. It need not be data science project. It can be any project whatsoever. And we have success criteria, in which you have the business success criteria, machine learning success criteria, and economic success criteria. Within machine learning success criteria, there are multiple things that you can once again look at. However, we primarily look at the accuracy, and secondarily, we look at performance speed. Economic success criteria is always related to money. And once you record your objectives and constraints, once you have a good understanding about the business problem that you're trying to solve, you move into the next phase, which is data understanding. Within data understanding, you go and collect the data. But before we collect the data, we should do some research to understand what kind of data should be collected. First, go to Google, probably Google Scholar. Try to look at what are the similar kind of problems which were solved in the past. Read those articles. Try to understand what kind of variables or data did people use. What kind of techniques did they use? That should be a good starting point. And then to capture that data, which will help you analyze better, we spoke about data types, wherein we discussed about continuous data, within which we spoke about interval and ratio data. And we also understood that ratio data is the best, because you can perform all the statistical analysis if you have ratio data. So you always need to prioritize and ensure that you first capture the ratio data. Then we have discrete data. Within discrete, we have categorical data and count data. Within categorical, you have binary and multiple. And within multiple, you have nominal and ordinal. Nominal data is the least preferred data. Then we have qualitative, quantitative, structured, semi-structured, unstructured. When you have unstructured data or semi-structured data, We try to perform data transformation, or we try to convert unstructured or semi-structured data into structured format. Then we discussed about big data, non-big data, what kind of databases we use. When we have big data structured, big data semi-structured or unstructured. And when we have non-big data and structured, what databases do we use? What databases do we use when you have non-big data, which is semi-structured or unstructured, is also something that we have discussed about. And then we spoke about cross-sectional data, time series data, longitudinal and panel data. We also discussed about the differences between balanced data set and imbalanced data set. Imbalanced data sets are also called as rare events. If the output variable is continuous, then when do you say that your data is balanced? And when do you say that your data are imbalanced? Data plural. Okay, hence sometimes I say data are. Anyway, when output variable is categorical in two categories, then how do you decide whether your data are balanced or imbalanced? If your output variable is categorical in multiple categories, then how do you decide whether your data are balanced or imbalanced? And then we have also discussed about batch processing or offline processing versus live streaming or online processing. Once we are clear with the data types, we proceed further with data collection, in which we have primary data and secondary data. Okay, Amen. We have a lot of additional stuff available for your reading. So we have primary data and secondary data. We first go after primary data, which is data we collected beforehand. Data is already available. You just need to go pick the data and start your analysis. But the flip side is that you may or may not have the data needed for your analysis. If you don't have the data needed for your analysis, you proceed further with primary data collection mechanism, wherein you perform surveys or design of experiments or simulation, web scraping, so on and so forth. The good part is you get the exact data which is needed for your analysis. But the flip side is that it is going to be costly and time consuming. And we have already discussed about conducting surveys. We spent some brief time to understand how to devise a survey and proceed further to, solve your problem of collecting the right data. Now let's look at another example of primary data collection, which is design of experiments. Okay, so let's get into that discussion now. When it comes to designing your experiment, you need to spend a lot of time to understand what are the key factors which influence your experiment. For example, say you're doing some marketing and you want to offer a discount. So should I send out 10% discount coupon, or do I need to send out 20% discount coupon to the customers? Either you send them over WhatsApp or do a text message or send out an email. But do you need to provide 10% discount or do you need to provide 20% discount? And then you have expiry date. If I say that coupons will expire in 2 days versus coupons will expire in 10 days, how would the customers react to it? If I say that within the next 2 days, your coupons will expire, would the customers be keen to go and purchase something? Or if I say that, within 10 days, your, coupons will expire, would the customers be more eager to go and purchase. We don't know. We need to experiment, right? But even before we experiment, we need to design the experiment. We need to understand what are the various factors and what are the various levels within that. Any variable which takes a limited set of values is called as a factor. For instance, this happens to be a factor. Coupon. And this factor has two levels. What are those two levels? 10% discount and 20% discount. These are the two levels. Expiry date is a factor. Why is it called as a factor? Because we have limited entries here. Either you have 2 days expiry or 10 days expiry. So you're trying to experiment with these two levels. If it need not be 2, it can be 3 or 4 or 5 or 6 or 7 or 100, doesn't matter. But as long as they're limited, you call it as a factor. For instance, if you have a variable called as gender, you know for a fact that it is a factor. Because you can have male, female, or probably a few other genders, but then those genders would be limited. If you talk about make of car, you can have a petrol variant or a diesel variant or a CNG or LPG, etc., electric vehicle. But the number of unique entries would be limited. You cannot have infinite makes of a car. Hence, this would also be called as a factor. And if you have 5 unique values, you say that this is a factor with 5 levels. Otherwise, in this case, in the case of gender, you say that it is a factor with 2 levels. Oops. Okay. Distance. Should we target the customers who are within 5 meters, 5 kilometers radius? Okay. Or do I need to target the customers who stay in 10 kilometers radius? So if my office is located here, then you look at 10 kilometers from there and you draw a circle, and within that region, you target your customers. That's called as 10 kilometers radius. Or you might want to have combinations to make things even more difficult in terms of performing the experiments. Okay, now, instead of individually experimenting with these factors, what if I were to combine these, such as 10% discount and 2 kilometers radius? How would people react? Versus if I provide a 12% discount and 3 kilometers radius, how would the customers react? Ultimately, it is data, data, and data, which would get generated, and you will have to look at this data and come up with informed decisions making. And if you're trying to market and increase the sales of any of your food products, then you need to consider a lot of additional factors, such as, if I were to provide such discounts on vegetarian food versus non-vegetarian food, how would the customers react? If I were to experiment with different cuisines, how would the customers react? Chinese, continental, whatever. Day of the week. If I'm going to send a coupon on Monday versus on a Friday, would the customers react differently? If I send it to them in the morning versus noon versus night, would they react differently? We don't know until and unless you capture the data and perform your experiments. And that is called as design of experiments. Here, I've provided a URL of analysis which was performed a few years back. And here, you have the time and how customers reacted. When you say that offer is valid only for the same day, then a lot of customers started redeeming the coupon. That means they started using that. And if you say coupons will expire in the next 2 days, only a few people overall redeem the coupon. So creating some kind of an urgency worked in this scenario. We really don't know what kind of a product it is, but for this product, it worked in that way. Does not mean this is how it's going to work for any product that you're going to sell. Next. If you're going to send coupon to someone who is at a far off distance, then only a few people might redeem because probably your location or your shop is very far away from that customer. So why do you want to even waste your coupons, right? Probably you need to send it to those customers who are very nearby. And when the combination was experimented, when people send it to someone who was far, someone who was at a medium distance, someone who was near, then how did the customers react? For customers who are far away, same day coupon worked wonderfully well. But then when you look at the customers who are at a medium distance from your shop, same day worked very well. But then next best happened to be 2 days prior. You're giving them 2 days time to redeem the coupon, and those kind of customers had the second highest redemption rate. If they're redeeming, that means they are purchasing something. And very interesting thing is for people who stay nearby, if we look at these two in silos as two different entities, we might feel that, you know what, here same day is very high. I mean, a lot of customers are redeeming the coupon. If you say that coupon is going to expire on the same day. However, when it comes to distance, the customers who stay nearby reacted very well. They came to your store and they started redeeming the discount. However, when you try to combine these two and then when you try to analyze, there is an interesting insight that is going to come out here. That is what is happening here. If you observe carefully, 1 day prior, for people who stay nearby, you need to send a coupon which will expire next day. You give them 1 day time to redeem, and then it is going to work out very well. Right? In for a pleasant surprise because we never expected this. But yes, when you experiment, only then can you understand what's happening behind the scenes. Okay, if you do not experiment, then nowhere will come to know about these things. All right. So that marks the end of how do you conduct, design of experiments. Now, let us understand about the different errors which can be avoided when you perform data collection. There are 4 errors which can be avoided during data collection. What are those errors? Error number 1, random errors. What if you're using a device to capture the data? It could be temperature, it could be wind pressure, it could be, the engine coolant level, whatever be it. If you're using a specific device to measure the data, and if your data is faulty, then the entire data on which you're going to analyze would obviously be incorrect. Why would it be incorrect? Because you're using a faulty device. So periodically, we are expected to, assess whether the equipments which are being used to capture the data are, still in good shape. Otherwise, you will end up capturing inaccurate data, and then you'll start analyzing on, inappropriate data, sorry, incorrect data rather. So there is a technique called as gauge, repeatability, and reproducibility. And this technique will help you determine whether the devices that are used to capture the data are still in good shape or not. Can we still go ahead and capture the data or measure without any errors? Then, sometimes the people who measure might have different thoughts on how to measure the data. For example, say you're measuring the weights of people. Okay, say you're measuring the weights of people. For one person, probably you measure the weight in the evening. For another person, probably you measure the weight during the morning. Another person, probably in the afternoon. One person, probably you measure the weight after consuming food. For another person, probably you measure the weight before consuming the food. All of these would give you, even if you measure for the same person, all of these would give you different weights. What if a few of the people who are involved in the experiment are, asking the people to come in the evening to, measure the weight? What if that person is saying you can come after having the food? What if another person is capturing the weights in the morning? And what if you say that you need to come here for the weighing before consuming food? Ultimately, you'll have different data, and your analysis would be biased. Your analysis might go wrong. To avoid that, you need to perform a technique called as attribute agreement analysis. Of course, there are various ways of measuring the data quality, but one technique that you might want to apply is attribute agreement analysis, which will ensure that all the people who are involved in measuring, follow a standard operating procedure. Okay. So we need to try and avoid such errors. Then there is something called as systematic errors. For example, if you go to Twitter, and this actually happened when Donald Trump was elected as US president, and it came as a shock for a lot of people, because when people started doing social media analytics, and when they analyzed the Twitter tweets, they found that huge or majority of them were against the ideologies which Trump had. They were talking negatively about Trump. But then when it came to the D-Day, election day, they all voted for Donald Trump. Why? Because maybe whatever Donald Trump is talking about, if you openly support those ideas and ideologies, people might not like you. So you have something else inside you, and we are portraying something else. We need to be careful in analyzing such data. If you still go ahead and take that data and analyze, that's called a systematic error. A few years back, not now, a few years back, people were capturing the data from the wearable devices, and they started predicting on what kind of diseases people might get. If someone is continuously seated in a location and following sedentary lifestyle, then they might get heart stroke, they might become diabetic, they might, put on a lot of weight, they might become, their body might be having a lot of cholesterol, so on and so forth. While people were predicting what kind of diseases people might get by capturing the data from wearable devices, one thing which happened a few years back was that only customers who were wealthy were using wearable devices, probably 5 to 10 years back. When you look at the wearable devices, not many customers had. Today, of course, a lot of people have it, but still. So if you take the data only of the wealthy customers and analyze and build a prediction model to predict what kind of diseases people might get, then your entire analysis would be biased towards wealthy customers. We need to take care of these things and we should not repeat these. Next, errors of choosing what to measure. For instance, rather than choosing a person from top university for a job, maybe we need to look at their social network on who all guided these people through a series of events, which made them join the top school. So if someone is admitted in a top university, and if you want to offer them a job, then probably you need to look at their social network. You need to probably look at whether very well connected to the university dean. Was that the reason why this person got an admission? Was this student who got admission into this top university well connected to the political folks, affluent people? Was that the reason why this person got admission? Not sure. We need to analyze. We need to understand. Next. Just because someone gets a very high score does not mean that their IQ levels will be higher. A lot of people who get a very good entrance score ultimately do not do very well when they come out of the college. Just getting a very good score for getting an entry into a few of the colleges does not really mean that that person has high IQ level. In countries where reservation system is still prominent, maybe they got, that's related to admission. Maybe that's the reason why they got admitted to a specific college where they have reservations based on economically weaker sections, maybe. And in this case, probably this guy got high SAT score because this guy had access to good tutors and they had the purchasing power to purchase good study material. Is this the reason why the student got high SAT score? Is it not related to the high IQ level? Who knows? And if someone is liking a subject, then obviously they would, put in a lot of effort into that because they like it, or they spend more time, maybe, who knows? And that might be the reason why they might get high score in that subject. If you're taking that data and analyzing, your results might be skewed. Because doing well in one specific subject does not mean you're going to do well in other fields or in the other subjects. We need to think through about all these aspects. Exclusion, errors pertaining to exclusion. Until a few years back, whenever you wanted to build models on cardiovascular diseases, on who are the people who might get heart strokes, who are the people who might get blocks in their arteries. Uh, when people started analyzing that, they have built models only based on data pertaining to men, because data pertaining to women wasn't captured. Not because women do not have a heart, right? Just because that data was excluded. It wasn't getting, recorded basically. When you analyze this kind of data, then obviously your results will be skewed because your almost entire data would contain cardiovascular diseases pertaining to men. Okay. And when you look at the election results, if you want to predict the election results in US, for instance, it will not, work out well because you do not have sufficient data pertaining to colored women candidates in US. Since you do not have the data, if you build prediction models to predict on who might win the elections, it might not be accurate because you do not have the data pertaining to colored women candidates. Okay, and you know what people are doing nowadays? They're trying to come up with a role called as Chief Diversity Officer. And this Chief Diversity Officer role is to ensure that you have right mix of people in the firm. You have right number of men or equal number of men and women of different age groups at different positions, right? So that different thoughts, different ideas flow together. Okay, unless you have that kind of a setup, the data that you will be capturing, you have to be cautious because it might be biased towards a specific gender. Then we need to ensure that we reduce the bias and we bring in the fairness when we collect data. For example, if you look at Amazon's facial recognition system, it was trained on white faces of white people. And when you have darker skinned faces, the algorithm wasn't working well. It wasn't detecting people well. Why did this happen? Because you were unfair in terms of selecting the data or in terms of collecting the right data. You collected more data pertaining to white people faces. Because of that, whenever you have dark skinned faces, your algorithm obviously will not work well because your algorithm has learned the white faces. It's like you prepared for your exam on a specific subject. What will happen if you get a question from a different subject? Say you studied physics, but suddenly you have a question pertaining to history. You might not be in a better position to answer that. Right? So whenever you have, whenever you collect the data, ensure that you bring in fairness into the data that you collect. One another thing is in US, especially, there are a lot of prediction models in the space of judiciary. In the space of judiciary, you have a lot of prediction models which are built. And you know what? In the underlying data set, historical data, which people have used, a lot of data was pertaining to Afro-Americans, Black people, right? Or darker skinned faces. Because of that, whenever you supply to those kind of models, images of a white face versus a dark face, chances are high that for a dark skinned person, they will have rigorous imprisonment, rigorous sentence. Whereas people with white face, they do not get severe punishments. The reason being, when they pass these images through the algorithm, machine learning algorithm, it would give you some results, but those results would be biased because you always, in the historical data, chosen a lot of Afro-American faces. On similar lines, when you build a loan default prediction model, you're not expected to use gender or race to build your algorithm. The moment you use gender, male and female, you're ensuring that you're going to approve or reject the loan based on gender as well. So that means you would be gender biased. Same is with race. Are you an Afro-American? Are you an Asian? Right? So on and so forth. Based on that, you cannot differentiate. You cannot say that I'm going to approve the loan or reject the loan based on the race that people belong to. Then you're not being fair. Hence, before you collect the data, you need to, bear in mind that you do not have these kind of errors in the data that you collect. And you also need to ensure that you have data which is bias-free and which includes fairness into the models that you build. Okay. So this is how you would ensure that you have quality data. Garbage in, garbage out. So if you collect inappropriate data, results also would be inappropriate. And when it comes to this crisp MLQ framework, friends, trust me when I say this, that approximately 60% to 80% of your time you would be spending only on phase 1 and phase 2 of crisp MLQ. Understanding the business problem, collecting the appropriate data, which is going to be bias-free and fair, and which doesn't have any of the errors that we have just discussed. And then cleaning the data, preparing the data, pre-processing the data, performing exploratory data analysis, etc., would constitute 60 to 80% of the entire project time. Roughly 20% of the time you spend, 20 to maybe 30% of the time you spend in building your machine learning algorithms and evaluating those. Then whatever time is left out, you deploy the models and you start monitoring the models. Okay, so that is how important the initial 2 phases are. And as a data scientist, you are expected to perform all these things. While you have a role called as data analyst, and you have a role called data scientist, a data scientist is also expected to perform the job of a data analyst. Usually in companies, you will have separate data analytics, separate data science teams. And in a few companies, you'll only have data science roles, and they are expected to perform data analytics work as well. Not expected, you have to. Until and unless you as a data scientist understand in and out of the data, you cannot build a decent prediction model. All right, so let's move on to the next phase. Okay, so this is what I wish to, talk about. And while I was visiting a specific company in Malaysia, where we have given a proposal for their data warehouse setup and building the analytics, I happened to see this from Usain Bolt, which is who is undoubtedly the fastest sprinter on the planet. Right? He retired recently, but then this is what he had to say. about his opponents. Right? He told us that kill them with your success and bury them with your smile. So you need not prove anything to the people. Okay? You just get jobs in data science. Obviously, the salaries are very lucrative. That's it. You need not even talk a word that speaks millions of words, right? Your silence is going to kill them. And then you just need to smile at them. Smile at them in the sense if you have any opponents for whom you want to prove a point. Okay.